corrosion reactions. So in layman's terms, or in the terms that you guys would already probably understand, corrosion is basically rusting. But it's not entirely accurate to say that, because rusting really only refers to iron, and in fact corrosion can occur on a whole range of metals. So chemically speaking, it's much better to say that corrosion is a chemical reaction that occurs between a metal and a substance in the atmosphere, usually oxygen. Obviously, we're very familiar with this term rusting because irons are very commonly used material and we see the effects of rusting all the time. So some corrosion reactions need the presence of water, and other corrosion reactions will be enhanced by the presence of salt water. As I said, corrosion is very significant because we see it a lot, and the problem with corrosion is the product is usually more brittle than the original metal. So we use metals a lot because of their hardness and strength. Unfortunately, in some cases, particularly rusting, the result is the product is much more brittle and loses those properties that we originally were aiming for. So a general equation for corrosion, we can say metal plus oxygen gives us metal oxide. So zinc plus oxygen gives us zinc oxide. Iron plus oxygen in the presence of water will give us iron oxide. That's the one we're all familiar with, rusting, which is why we always generally associate rusting occurring in, or corrosion occurring in moist places, because we're so familiar with this rusting one. So what we're going to do is a little sort of thought experiment now, testing the conditions to confirm that those conditions are the ones that are most suitable for corrosion. So what we're going to do is we're going to place an iron nail into 4 different test tubes with different concentrations of oxygen, water and salts. So the most rust should occur in the test tube with the best conditions for rusting or corrosion. So here are our 4 different test tubes. So one with the salt water and the iron nail. That salt provides the added electrolytes. The boiled water, the reason we boiled it is because now we're going to have no dissolved oxygen in it. That layer of oil on top stops the air or the oxygen from dissolving into the water. The third one here is just our plain water, and our last one is got a stopper on top and some desiccant in the middle, down the bottom. The desiccant absorbs the moisture, so no more moisture is going to be getting in, so it's completely dry conditions in there. The result we would, as you'd anticipate, is that we're going to get rusting occurring on the first and third one, and nothing on the second and fourth. Now, it should be pretty clear why this is the case, that the second one did not have any oxygen in it, and therefore corrosion couldn't occur, and the last one didn't have any water, so no corrosion could occur. So we can now say that iron needs oxygen and water to rust, and this process is enhanced by the presence of salt, because we've got a much higher level of rust on that salt water test tube. So I hope you have a better understanding now of corrosion reactions. Very simply, we can just say it's a reaction. In a very simplified way, we can say it's just a reaction of a metal with oxygen, but as you can see, it's more accurate to say with things in the atmosphere, because obviously sometimes we need salt and water for these things to occur. If you have any further questions, do not hesitate to contact your teachers.